Let's learn math.
Hello everyone! Welcome to my video lesson. I am Christine A. Malto, your grade 10 mathematics teacher for this video. Our lesson for today is all about geometric sequence. So in this lesson, we are going to identify what is geometric sequence and geometric means, learn and familiarize the formula in finding the missing terms of a geometric sequence, and then learn how to find the nth term and geometric means of a given geometric sequence. So the sequence 32, 16, 8, 4, 2, and 1 is an example of geometric sequence. But what is geometric sequence? A geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by a non-constant called the common ratio. The common ratio R can be determined by dividing any term in the sequence by the term that precedes it. So in our sample geometric sequence 32, 16, 8, 4, 2, and 1, our common ratio is 1/2. Because when we divide the term by the term that precedes it, we'll get 1/2. So here we have 16 divided by 32 is equal to 1/2, 8 divided by 16 is equal to 1/2, 4 divided by 8 is equal to 1/2, 2 divided by 4 is equal to 1/2, and 1 divided by 2 is equal to 1/2. So therefore, our common ratio is 1/2. Now that we have already found the common ratio, we can now easily find the next few terms of this sequence by multiplying the last given term to the common ratio. And this would be our first method in finding the next few terms of our geometric sequence or even the nth term. So in our sequence, we have here 1, the last term, times the common ratio 1/2 is equal to 1/2. So our next term for this is 1/2. Then to get the next term again, we'll just have to repeat the process. So we have here 1/2 times 1/2 is equal to 1/4. So our next term will be 1/4. If you want to find the next few terms of this sequence again, you just have to keep repeating the process. Seems so easy, right? But how about if we are asked to find the 20th term? How about 50th term? Or 100th term? Are we gonna keep repeating the process again and again? Yes, we may, but that's very time-consuming. So for us to get the nth term of a given geometric sequence fast, we just have to use our next method, which is using the formula a sub n is equal to a sub 1 times r raised to n minus 1. In this formula, a sub n is our nth term, or the term we are trying to find. A sub n is our first term, r is the common ratio, and n will be the number of terms or the given term. Now let's try to find the 12th term of our previous example using the formula. So in here, our a sub 1 is 32 since 32 is our first term. Our r is 1/2 since 1/2 is our common ratio. And since we're trying to find the 12th term, therefore our n is 12. So let's substitute these values into our formula. Since we are trying to find the 12th term, so our a sub n now would become a sub 12, then substitute 32 to a sub 1, 1/2 to r, then 12 to n, and then we just have to copy minus 1. With our PEMDAS rule, we have to solve first the exponent. So we have a sub 12 is equal to 32 times 1/2, and this will become 11. Now we'll have to raise 1/2 to 11. So this is just simply multiplying 1/2 11 times by itself. So this will become a sub 12 is equal to 32, and this will become 1/2048. Then we will multiply 32 by 1/2048. So this will now become a sub 12 is equal to 1/64. So the 12th term of the sequence 32, 16, 8, 4, 2, and 1 is 1/64. Let's have another example. let's try to find the 7th term of the sequence 1, 6, and 36. Since 1 is our first term, so 1 will be our a sub 1. Then our common ratio r will be 6 because when we divide the term by the term that precedes it, we'll get 6. In here we have 6 divided by 1 is equals to 36. 36 divided by 6 is 6. Therefore, our common ratio is 6. And since we're trying to find the 7th term of this sequence, so our n would be 7. So let's substitute these values into our formula. So a sub n now would become a sub 7 since our n is 7 and we are also trying to find our 7th term. Then substitute 1 to a sub 1, 6 to r, n to 7, then copy minus 1. Again, then this rule, we have to solve first the exponents. So this will now become a sub 7 is equal to 1 times 6, and this will become 6. Then we'll raise 6 to 6. So this is just simply multiplying 6 by itself 6 times. So we now have a sub 7 is equal to 1. Then this will now become 46,656. Then multiply 46,656 by 1. So we have a sub 7 is equal to 46,656. Therefore, the 7th term of the sequence 1, 6, and 36 is 46,656. Okay, now that we have already learned how to find the nth term of a geometric sequence by multiplying the last given term to the given ratio or by using the formula a sub n is equal to a sub 1 times r raised to n minus 1, let us now try to solve this real-life problem. So here we have Michael saved 50 pesos in January. Suppose he will save twice that amount during the following month. How much will he save in December? To solve this problem, we have to use our formula a sub n is equal to a sub 1 times r raised to n minus 1. Since 50 is the first amount that Michael saved, therefore we let 50 pesos as our a sub 1. Then our r would be 2 since Michael will save twice that amount during the following month. Then n would be 12 since December is the 12th month and there are 12 months interval from January to December. Now let's substitute these values into our formula. Since we will find the amount that was saved in December, therefore a sub n now would become a sub 12. Then a sub 1 would become 50, r will be substituted with 2, then n will become 12. Then we'll just have to copy minus 1. PEMDAS rule again. We have to solve first the exponent. So this will now become a sub 12 is equal to 50 times 2 and this will become 11. Then we'll raise 2 to 11. So this is just simply again multiplying 2 by itself 11 times. So we now have a sub 12 is equal to 50. Then this will now become 2048. Then multiply 2048 by 50. So we now have a sub 12 is equal to 102,400. Therefore, Michael can save 102,400 in December if he will twice the amount of his savings during the following month of January. Okay, we have already learned how to find the next few terms and the nth term of geometric sequence and apply that in solving real-life problem. But how about if the geometric sequence goes like this? Just two given terms with no common ratio and in-between terms. You know what? Inserting a certain number of terms between two given terms of a geometric sequence is an interesting activity in studying geometric sequences. We call the terms between any two given terms of a geometric sequence the geometric means. So in the sequence 11, 22, 44, 88, the geometric means here are 22 and 44. And in geometric sequence 4, 8, and 16, our geometric mean here is 8. The question now is, how are we going to find the geometric means of a given geometric sequence? So to find the geometric means of a geometric sequence, we will find the common ratio first using the formula a sub n is equal to a sub 1 times r raised to n minus 1 again. And this time, a sub n is the last term or the other given term aside from the first term. A sub 1 still be the first term, r still be the common ratio, and n will be the number of terms of the given geometric sequence. So let's try to find the three geometric means between 5 and 3,125. So for the meantime, let's let the second term as a sub 2, third term as a sub 3, and fourth term as a sub 4. Now let's find a sub 1. So our a sub 1 here will be 5 since our first term is 5. Then our n would be 3,125 since 3,125 is the last term or the other given term. Then n will be 5 since we have 1, 2, 3, 4, 5 terms. Now let's substitute these values in our formula. A sub n will be substituted with 3,125, a sub 1 with 5, then we just have to copy r since we still have no value of r and it is what we are trying to find. Then let's substitute n with 5, then let's just have to copy minus 1. Again, time this rule, so we have to solve first our exponent. So this will become 3,125 is equal to 5 times r, and this will become 4. Since we still have 5 on this side, so we have to divide both sides by 5 to isolate r to the power of 4. So 3,125 divided by 5 will become 625. And 5 times r raised to 4 divided by 5 will become r raised to 4 na lang. To get the value of r, we have to extract both sides by 4. So we now have r is equal to positive and negative 5. So we have two solutions for this sequence. We have positive 5 and negative 5. So if r is equal to positive 5, our a sub 2 or second term will be 25. So we have here 5 times the common ratio 5 raised to 2 minus 1 will be 25. So to find a sub 3 and a sub 4, we'll just have to repeat the process in a sub 1. But we have to replace the value of n depending on what term we are trying to find. So with that, our a sub 3 or third term will be 125. Then a sub 4 or fourth term will be 625. So if the common ratio is equal to positive 5, our sequence will be 5, 25, 125, 625, and 3,125. If r is equal to negative 5, our a sub 2 or second term will be negative 25. So we have here 5, the first term, times the common ratio 5 raised to 2 minus 1 is equal to negative 25. Then our a sub 3 or third term is 125. And our a sub 4 or fourth term will be negative 625. So if our common ratio is equal to negative 5, our sequence will be 5, negative 25, 125, negative 625, and 3,125 with a geometric means of negative 25, 125, and negative 625. Okay, we have already learned how to find the geometric means of a given geometric sequence. Now let's try to apply that by getting the geometric means of our previous real-life problem. We already know that the answer of this is 102,400. So in January, Michael saved 50 pesos. And in December, Michael will have 102,400 pesos. And on this problem, we know our ratio is 2 since the amount will be twice during the following month. And we also know that the month in between January and December are February, March, April, May, June, July, August, September, October, and November. Therefore, the amount in January will be our first term, and the amount in December will be our last term, and the month between January and December would be our geometric means. So to illustrate this, let's take a look with this. So we let our second term or second month as a sub 2, and our third term or third month as a sub 3, and our fourth term or fourth month as a sub 4, and so on and so forth. Okay, so from the given values, we let a sub 1 as 50, and our last term as 102,400, and then our R as 2. Now let's calculate all the geometric means from February to November using our formula and our given values. So our a sub 2 now will become 100. We have here 50 as a sub 1, then common ratio 2, the number of terms which is 2 since we are finding the second term. So 2 minus 1 is equal to 1, then raise 2 to 1, so it would be 2. Then multiply it by 50, so the answer would be 100. So for a sub 3 to a sub 11, we just have to keep repeating the process. We just have to substitute the values to the formula to get the value of each term. So our a sub 3 now would become 200, a sub 4 would be 400, a sub 5 would be 800, a sub 6 would be 1,600, a sub 7 would be 3,200, a sub 8 would be 6,400, a sub 9 would be 12,800, a sub 10 would be 25,600, and lastly, a sub 11 will be 51,200. Therefore, the geometric means or the amount in the month between January and December that Michael have saved are 100, 200, 400, 800, 1,600, 3,200, 6,400, 12,800, 25,600, and 51,200.
And that's it! Now let's have a quick summary on all the things we have discussed. Again, geometric sequence is a sequence that can be obtained by multiplying the preceding term by its common ratio. And to get the common ratio, you just have to divide any term of the sequence by the term that precedes it. And for you to find the next few terms of a given geometric sequence, you just have to multiply the last given term